edexcel further mechanics 1, chapter 1, momentum and impulse. Let's do this mixed exercise with number 2. A pile driver of mass 1000 kg drives a pile of mass 200 kg vertically into the ground freely, a vertical distance of 10 meters before hitting the pile. So maybe 200 gram is here, and this 1000 kilogram comes like this, and try to dig in. So this is the one. So assume that they both move with the same velocity immediately after, okay. Particle. Then speed up the drive immediately before it hits the pile. So before it hits the pile means it fell down, and we can use the subat because it has only gravity. So let's make this direction the positive. Then 2as becomes, because there is no time information here and we don't need to know about it. So 2as is v squared minus u squared. So 2, 9.8, and distance 10 becomes v squared minus 0. So when I do that with calculator, 2 times 98, 14. So v is 14 meters per second. And common speed of the pile and driver immediately after the impact. So, wait. Oh, not like this. Because we don't need this. And let's make it white. Okay, so I will write here. So now, this was number A, and number B, common speed of pile and driver immediately. So this is the first, what is that? The initial velocity now. So now U is 14 meters per second. But it is just at the moment, so we can think about the momentum. So velocity times the kilogram. So the first, right before it hits it, 1000 times 14. And as soon as meet them together, 1200 and the new velocity. So like this. So 70 over 6. So 11.67 meter per second. So this is, so let me do it. So 3 over 35. And number C. Ground provides a constant resistance to the motion of pile driver of magnitude. So now they are together. So they just comes like this, 1200 and velocity. No, I mean this is the power. So I need to make the Newton units. So MA. So now we have the gravity, and the resistance is 120,000 Newton. So this makes the resultant the force. So let's call it A. So 1200A becomes, this is the same direction, 1200G minus 120,000. So the A is gravity minus 100. So 9.8 minus 100 becomes 90.8 0.2 meter per second squared. So number C, so this is the acceleration, and now we need to find the distance. We know the acceleration, so we use again. So from Subat to AS becomes v squared minus u squared. So the common speed was this one. So this is the initial speed. So 11.67 squared here. Minus, now we go to the rest. So 0 squared becomes a 2, negative 90.2 s. So s becomes 11.67, so 35 over 3 squared over 2 over 90.2, so 0.754 meter. So number D, pilot immediately after the impact. Here the model assumes that they both move the same velocity here. So actually, when the two here they call it particle, but like this, when they meet together, conflict together, actually there is the bounce or like rebound. But we assume that there is no such things. So this maybe affect the real result. So number 7. Yep. Particle A of mass m is moving with speed to u. Okay, so like this. So U1, U2, V1, V2, impulse. So this is mass m, and initial speed 2u. Line is horizontal table, so we don't need to think about the friction kind of thing. It collided with another particle B, km, speed u, opposite direction, but it is like a negative u because it's opposite. In the collision, particle from a single particle, speed t 2 over 3u in the original direction of a motion. So 2 over u and 2 over 3u. So find the value of k. Okay. So when we use this preservation of the impulse, so 2u and the formula is mv. So let's do that. So here, mv, m2u plus km negative u equals, they are now same, m 2 over 3u plus km 2 over 3u. So now we can remove all m and u. So 2 minus k equals 2 over 3 plus 2 over 3k. So 5 over 3k becomes 4 over 3. Therefore, k becomes 4 over 5, 0.8. And number 8, metal pin of mass. Okay, let me add metal pin of mass 2 kilos driven vertically into the ground. So it was quite similar with the previous one. Mass 10 kilogram. hammer falls vertically on the pin, speed just before impact being 9 meters per second. Model situation assume that after impact, the pin and hammer stayed in contact and moved together before coming to rest. Pin immediately after impact. So this is like common speed. So 10 times 9 becomes 10 plus 2 times v. So the velocity is 3, 4, 2, 5, so 7.5 meter per second. And number B, the pin moves 3 centimeters into the ground before coming to rest. 3 centimeters, like S is 0.03 meter. And V is 0 now. U is 7.5. Assuming in this model that the ground exerts this constant resistance force, R Newton as the pin is driven down, value of R. Okay, so again. So now we impact like 12 together and G. But the resistance is here, R. And altogether, the 12A. So 12A becomes 12G minus R. So R becomes 12G minus A. But now, because we know this is 3 centimeters, so we can find A from here. So 2AS is V squared minus U squared. So this is the one and 7.5. Negative 7.5 squared over 0.06. So A is negative, is quite high, 937.5 meter per second squared. So when we put it here, 12, 9.8 minus negative 937.5. So 12, 9.8, 937.5. So 11,367.6 Newton. And C, state one way in which this model might be refined to be more realistic. Maybe we can consider, like, now we assume this as soon as they meet together, we assume that they move together without any further interaction between them. But there will be the interactions like bounce or something, then we can consider something like that. And number 12, particle P of mass 0.3 is moving. Position vector R is here. So this is the position. And now, calculate the speed. Because this is, we can say T. When T equals 4, R equals 4 to the power of 3, 4 to the power of 2, 4 and 4, I plus 44J. So speed. Oh, so this is the position at 4. So let's call it, let's find the velocity vector. So 3t squared to t plus 4, I plus 11j. So when we put t4, then velocity equals 1648 plus 8 plus 4, I plus 11j. So speed is magnitude of velocity. So 12, 60 squared plus 11 squared. So square root 60 squared plus 11 squared, 61. So speed is 61 meter per second at t equals 4. So 61 meter per second. And number B, velocity of p immediately after the impulse. So now when t equals 4, the impulse was this one. So as we find the impulse with the terminal velocity times mass, like mv minus mu. This is impulse. So let's make it. So impulse is 2.4 I plus 3.6 j becomes 0.3 v minus u. So the initial velocity, terminal velocity is just now we found 60I plus 11J minus initial velocity, what was it? Yeah. So right after immediately after the impulse. So when t equals 4, so it arrived to t equals 4, like here. But now it affects. So I is at the 60I and 11J is the initial velocity. Terminal velocity. But this is the initial velocity because when it arrived, there was another condition with this impulse. So we don't know what is v minus 60I plus 11J. Like this. So 8I plus 12J plus 60I plus 11J becomes the velocity. So the velocity is 68I plus 23J meter per second.